We can use the mole, and we can use molar masses to determine formulas. And we can go the other direction and take a formula and turn percent mass. Percent mass. Percent mass might be useful if, for example, we want to know just how much carbon is in your body or how much hydrogen. So if you looked at your body, you probably have the greatest percent by type of hydrogen. But if you look at the greatest percent by mass, hydrogen's pretty light stuff, so it might not be percent by mass lightest element in your body is hydrogen. Does that make sense? So this is kind of what we're looking at here. I'm going to give you a formula. We're going to say C6H12O6. And I would like you to tell me percent by mass, how much of each element do you have? Percent by mass. So how could we do this? This is our compound, and we want to separate it out. It would be similar to me saying, okay, percent by mass, I have girls, I have boys. What is my percent by mass of girls and boys in this classroom? And you could take the mass of the girls and the mass of the boys. You have total mass of the class. And then you could divide mass by girls by the total mass, mass of boys by the total mass. And you would have percent of mass girls, percent of mass boys. Does that make sense? So we're going to do carbon, hydrogen, oxygen. What do we have 6 carbon, we have 12 oxygen, and we have, 12 hydrogen, 6 oxygen. Okay, so let's look at, by mass, what's the mass of carbon? 12.01. And we have 6 of them. We have 12 hydrogen, the mass of that is 1.01. We have 6 oxygen, the mass of that is 16.998, or we'll just round that to 16.00. And this is 72.06. And this is 12.12. And this is 48. No, it's bigger than that. 96.00. Okay, you have just figured out, we're going to name this, here's a vocab term for you, mass contribution. All right? You have figured out the mass contributions of those elements. You will actually use a process just like this when you pay taxes from time to time, where you have to consider the percent contribution of different assets and incomes that you have. Okay. What's the total mass? Total mass. Can you now tell me the mass percent? You have the mass contribution of carbon, and you have the total. So you just take 72 and divide it by the total times 100. And you're going to round it to, sure, you can round it to 468. That's good. What do you get? You have to multiply by 100 to make it a percent, and it becomes 39 point, my pen is dying, 39 point, okay. Very good. Let's do the next one. Mass percent, 12.12 divided by total mass, 180.18 times 100. We'll just say 73%. Keep it to the 100. Yes, we were doing 468. But this kind of only had 3 over here, so I gave it 3. And then should this be? What was the contribution of this? 96 divided by 180 times 100. Point what? These should add up to 100, right? Because they are percent. You're taking, this is the contribution of the carbon. So you could tell me this is the percent carbon. Maybe I'll label it on the bottom. 39.9% carbon, 6.73% hydrogen, just to make sure we're clear, and 53.28% oxygen in glucose. So a large percent carbon and a large percent oxygen. Not very large percent hydrogen, even though if you look molar-wise, there are many more moles of hydrogen. Does that make sense? Is that interesting? Okay, that's the easy problem. I think it's pretty easy. And I guarantee you on your exam, I'm going to give you a choice. You can either do this type of problem or the next type of problem. And you can try to do both. You just want to earn some points. No, you won't get any extra credit, but you will guarantee that you've demonstrated enough knowledge to earn your A or whatever good grade you want. Second type of problem. Do you want to do it now or do you want to practice some of these and pause? Do it now. Okay. Second type of problem. Remind me to print this out for Connor so he has these notes, because he is at golf. Okay, I need you guys to open your textbooks for this type of problem, because we need to have some math spec readings from Hodgins. I don't memorize these results that you might hear. Page 337. Page 337. Or we could do 336. Let's do the top of page 336. It says, calculating an empirical formula for mass data. Although the mineral ilmenite contains more iron than titanium, the ore is usually mined and processed for titanium. A strong, light, flexible metal. Titanium is very useful stuff. A sample of ilmenite is found to contain, let's start writing down our given information. It's what we always do, right, Haley? They've given you that they have 5.41 grams of iron. They also tell you their mass spec instrument said 4.64 grams of titanium. We are writing this given information down. Titanium. And 4.65 grams of oxygen. This is why oxygen is the second most abundant element in the Earth's crust, because it's always bonded to all these metals, all these oxides. Okay, so 5.4 grams of iron, 4.64 grams of titanium, and 4.65 grams of oxygen. Determine the empirical formula for ilmenite. Okay, you have been given these grams. The formula we were just looking at, a formula tells you what? Doesn't tell you grams, it tells you moles. Can we go from grams to moles so we can write a formula? Because formulas, those little subscripts, you gotta have those little subscripts. How do you figure out what those subscripts are? Figure out how many moles you have. Can you figure out how many moles you have? Yes, you can. You can look on the periodic table and say, if I have 5.41 grams of iron, I can convert this. I want to get rid of grams, and I want to go to moles. Don't I have an equivalency here? Can I look on my periodic table and use the atomic mass number, put it in grams to find out moles? 5.41 4.85? Yes, I can. And that is going to tell me mole, right? And I'm going to be able to cancel grams. What do we get? 0.09. Let's keep these 3 sig figs. 969. That is 3 sig figs. This 0 is just a placeholder. It has to be after a zero, after a number and a decimal to be significant. Okay, how about titanium? 1 mole of titanium our number for titanium is 47.9, 0, and oxygen 16.00. Mole of oxygen. Okay, I've set up all my conversions now. We good so far? Okay. 4.64 grams divided by 47 is going to be close to this number here, actually, isn't it? It's the same number. How nice. How nice. Okay, and this, 4.65 divided by 16? Okay. What is this stuff? Oxygen? We could write a formula. You want to see what this formula would look like? Let's write it. Fe 0.0969, titanium 0.0969, and oxygen 0.291. What? That doesn't look like any formula I've ever seen. Is it accurate? Sure. Is it easy to write? No. People like formulas to be in. We need to put this into the simplest ratio. This is not a simple ratio. But we can make it simple. We can make it nice whole numbers. Simplest, let's say that. Whole number. I'm not going to write the words. Probably better. Simplest whole number ratio. That's what we need. Here's what you do. Divide all of them. As long as you do everything across the entire formula, you're legit. We're going to divide them all by the smallest. Divide them all by 0.0969. 0.0969. 0.0969. So, what do we get? We get 1, 2, 3. Oh, that sounds like a good formula. Iron, titanium, oxygen, 3. Here's your answer. That looks like a formula. We can work through, like if you, for example, if you had 1.5 here, 1 and 3, you can multiply everything by 2 and get a whole number. Yes. 1.3. What if you had 1.3? Could you multiply everything by 3? And then you get 9. If you're at 0.9 or 0.1, you may round. If you're at 0.9 or 0.1, you can either round up or round down. If you're that close, if you're within a tenth of it. All right? If you're anything more, you're going to want to multiply by 3 or multiply by 2 to get it where you need it. 1.3, if I multiply it by 3, I'm going to get 3.9, and then I can round it to 4. That's what we're going to do. Can we write down the steps of how we solve this problem so we can use it every single time to solve problems? What was the first thing we did? We're doing this to find empirical formula. So we wrote given masses, and then what did we do? We converted mass to moles. How did we do that? Divide by molar mass. What was our next step? Simplify by, what was our first thing when we simplified? We divided all by the smallest molar amount. And then if we needed to, if needed, multiply all, important you understand you have to do all of them, by 2 or 3 to get whole numbers for the formula. All right? And that's how we do these problems.